Today we are doing lesson 16.5 and 16.6, reading and writing scientific notation. Our I can statements today: I can identify numbers written in scientific notation. I can write numbers in standard form. I can compare numbers in scientific notation. I can write large and small numbers in scientific notation. And I can perform operations with numbers written in scientific notation. So our key idea for the first part of this lesson: scientific notation. A number is written in scientific notation when it is represented as the product of a factor and a power of 10. And the factor must be greater than or equal to 1 and less than 10. So between 1 and 10 has to be your first number. And then the second one is 10 to some power. If that power is more than 1, then it's going to be a bigger number. If it's something like this with a negative exponent, it's going to be become a smaller number because this represents a decimal that's less than 1. All right, so for each one, the first type of problem, we are just saying yes or no if the number is written in scientific notation. So for the first one here, we have 5 9/10 times 10 to the negative 6. Yes. And that's because your first number is between 1 and 10, can be equal to 1. But I'm going to write between 1 and 10 and is multiplied by a power of 10. Okay, and then our next one, 9/10 times 10 to the 8th power. No, 9/10 isn't between 1 and 10. So you need a yes and no, and you also need an explanation why. All right, let's look at our next key idea: writing numbers in standard form. The absolute value of the exponent indicates how many places to move the decimal point. If the exponent is negative, you move the decimal point to the left. If the exponent is positive, you move the decimal point to the right. All right, so write 3 22/100 times 10 to the negative 4th power in standard form. This negative exponent tells us that our starting number, 3 22/100, is going to become smaller. In order for it to be smaller, the decimal is moving to the right, left 4 spaces for that 4 in the exponent. 1, 2, 3, 4. Okay, now I've got to put in some placeholder zeros. So I'm going to put a 0 in the front. There's my decimal. Then I need 3 placeholder zeros. So my standard form number is 0.000322. If I have scientific notation and my exponent is negative, my standard form is going to be a decimal that's less than 1. Write 7 9/10 times 10 to the 5th power in standard form. So same thing, except now I have an exponent that is positive, which means my number is going to get bigger as I write it. 7 9/10. Okay, 5 places. 1, 2, 3, 4, 5. That's where my decimal's going. I'm putting in some zeros as placeholders. 1, 2, 3, 4. Okay, I did need a 0 there. Okay, and then I'm going to put a comma in. I'm going to rewrite it so it's nice and neat. So I have 790,000. Scientific notation is handy for taking a number that's really long and making it easier to read and write without having to write a whole bunch of zeros in the front or the back of that number. All right, go ahead and pause the video. Try these next 4 on your own. All right, let's check our answers. So number 1 is 12 times 10 to the 10 to the positive 4th power written in scientific notation and explain. No, 12 isn't between 1, and 10. Okay, write the number in standard form. 6 times 10 to the 7th power. We have a positive exponent. Our number 6 is going to get bigger. 1, 2, 3, 4, 5, 6, 7. Holy moly, we're going to add a lot of zeros here. 1, 2, 3, 4, 5, 6, 7. Okay, so when I put my commas in, I need a comma here. I need a comma here. That is going to give me 60 million. All right, let's take a look at our next one. 9 and 9/10 times 10 to the negative 5th power. Negative exponent, my number in the front is going to get smaller. That means I'm moving my decimal to the left. 1, 2, 3, 4, 5 places to the left. I'm going to add a 0 in front. 1, 2, 3, 4 zeros in those placeholders. 0.12349 is my answer. All right, let's take a look at this next one. 1 and 285 thousandths times 10 to the 4th power. My exponent is positive, so my number is going to get bigger. 1.285. Decimals moving 4 places to the right. 1, 2, 3, 4. So I just need one placeholder 0 here. My comma would be going there. 12,850. All right, let's take a look at a story problem. An object with a lesser density than water will float. An object with a greater density than water will sink. Use each given density in kilograms per cubic meter to explain what will happen when you place a brick and an apple in water. So I am going to take these numbers and I'm going to compare them. And to do that, I'm going to go ahead and put them into standard form to start with. And then we'll take a look at how we could compare them in scientific notation. So water is 1 times 10 to the 3rd. Positive exponent, my number is going to get bigger. So 1.0, 1, 2, 3. So my number for water is 1,000. Okay, brick, 1.84 times 10 to the 3rd power. 1, 2, 3 spaces. I get 1,840. Apple is 6.41 times 10 to the 2nd. Positive exponent, the number's getting bigger. 1, 2 places. That's going to be 641. Okay, so we're comparing them to water. Now, you might already know what happens when a brick goes in water and when an apple goes in water, but we're using the numbers to help us. So brick will sink because 1,840 is greater than 1,000. And then the apple will float because 641 is less than 1,000. Now, if I didn't want to make these into standard form to compare them, I can take a look at my numbers and my exponents. So I can compare them by comparing the exponents. 10 to the 3rd means I have a number in the thousands place. So I have a number in the thousands, I have a number in the thousands, and then I have a number in the hundreds because this exponent is smaller. So the smaller exponent here tells me that the number overall is going to be smaller. Now, if the exponents are the same, then you look at the numbers in the front. The bigger number in the front means the number's bigger overall. You can compare them in scientific notation, but you can also take the scientific notation, put it in standard form, and then use that to compare. All right, let's take a look at this next one. A dog has 100 female fleas. How much blood do the fleas consume per day? And then off to the side it says a female flea consumes about 1 4/10 times 10 to the negative 5th liter of blood per day. Okay, so we have 100 female fleas times the scientific notation. I'm going to put it in parentheses, 1.4 times 10 to the negative 5th. All right, so I'm going to go ahead and just change this into standard notation, and then I'll multiply it times the 100. We will look later in the chapter about how to do it with the number in staying in scientific notation, but for today, we're just going to do it in standard form. Okay, so 1.4. 10 to the negative fifth means that I am moving my decimal place 5 places to the left because my number is going to become a decimal less than 1. All right, 1, 2, 3, 4, 5. There's my decimal. And I fill in my numbers. Okay, so I have 0.0000014. Okay, and then I'm going to multiply it times 100. Okay, so when we do multiplication and we have a decimal, we need to make sure that our final answer has the same amount of decimal places as the number that we start, our numbers in our problem. So I have 1, 2, 3, 4, 5, 6 numbers that are decimals in my problem. Okay, so I'm going to forget about all of these extra zeros right now. And I am going to just multiply it as if it was 100 times 14. All right, so 4 times 0 is 0, 4 times 0 is 0, 4 times 1 is 4. Add a placeholder 0, 1 times 0, 0, 1 times 0 is 0, 1 times 1 is 1. If I add those together, I get 0, 0, 4, 1, 1,400. Okay, but now I need to go back and put in 6 decimal places. 1, 2, 3, 4, 5, 6 decimal place. Now when I'm writing my final answer, I actually don't need these 2 decimals now at the end because they're just zeros. So I'm going to write 0.0014 liters per day. All right, go ahead and pause the video and try these 2 on your own. Okay, let's check our answers. So what if in example 3, the density of lead is 1 and 1400ths times 10 to the 4th power kilograms per cubic meter? What happens when you place lead in water? Okay, so we know that water, remember the density was 1,000. Okay, so 1.14 times 10 to the 4th power. All right, we're going to move our decimal 4 places to the right because our number is more, that our exponent is more than 1. 1, 2, 3, 4. So that gives me 11,400. Okay, so it will sink. All right, what if in example 4, a dog has 75 fleas? How much blood do the fleas consume per day? So this time I'm doing 0.0000014 times 75. I'm going to forget about all these extra zeros for a minute. I'm just going to multiply it like 75 times 14. 4 times 5 is 20. 4 times 7 is 28, plus 2 is 30. Placeholder 0, 1 times 5 is 5. 1 times 7 is 7. Add those together, 0 plus 0 is 0, 0 plus 5 is 5, 3 plus 7 is 10. Okay, I had 6 decimals in my problem. I need 6 decimals in my answer. It's really hard to read my numbers because they're squished in down there. There we go. That's a little bit better. Okay, so I need a 0.00. I have 1, 2, 3, 4, 5, 6 decimals in my answer, just like I had in my problem. I don't really need that last 0 though, so I could do 0.00105 liters per day. All right, so all of that is the 16.5. Let's go ahead and take a look at 16.6. So our first key idea for this one, in our last part, we were looking at numbers in scientific notation and then writing them in standard notation. For this part now, we're doing the opposite. So to write numbers in scientific notation, we move the decimal so it is located to the right of the leading non-zero digit. That means you're taking our number and making it into something between 1 and 10. Then you count the number of places you move the decimal point. This indicates the exponent of the power of 10 as shown below. So if I had a number greater than or equal to 10, we have a positive exponent. If I have a number between 0 and 1, so I have a decimal, then I'm going to have a negative exponent. Okay, decimal, negative exponent, greater than 1 is going to have a positive exponent. Okay, so let's go ahead and try it. Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. All right, so I'm going to start by just writing it out. I want to make sure I get all those zeros down. Okay, so my decimal is going in between my first two numbers that are not 0. So that's the 1 and the 6. Decimals go in there. Then I'm counting how many places I moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9 places is how far I moved it. So I have 1.65 times, I'm getting rid of all the zeros, 10 to the 9th power. All right. The 2004 Indonesian earthquake slowed the rotation of Earth, making the length of the day 0.0000268 seconds shorter. Write this number in scientific notation. Okay, so I'm going to start with my number. Let's make sure I have the right number of zeros. 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5 zeros. And then 2, 6, 8. So the decimal goes in between the first two that are not zeros. So that would be in between the 2 and the 6. Then I count how many places I moved it. 1, 2, 3, 4, 5, 6 spaces. So I'm going to have 2.68 times 10, and then this is going to be a negative because I started with a number that was a decimal between 0 and 1. All right, go ahead and pause the video and try these 6 on your own. All right, let's check our answer. So I'm going to go ahead and put my decimal right here. All right, let's see how many places I did. 1, 2, 3, 4. So I'm going to have 5, and I could have it 5 or 5.0, either is fine, times 10 to the 4th power. So 5.0 or just 5. Sometimes you see scientific notation with a decimal no matter what, sometimes you don't. So either one of those is equally fine. Okay, number 2, I need to put my decimal in between my first two numbers that are not zeros. So 2.5. And then I need to see how far I multiplied, how many spaces. 1, 2, 3, 4, 5, 6, 7. So 2.5 times 10 to the 7th power. 683. That decimal is going to go in between the 6 and the 8. That's 2 spaces over. So 6.83 times 10 to the 2nd power. Okay. Those were all positive exponents because I started with numbers that were greater than 1. Now I have numbers that are between 0 and 1, decimals, so they're all going to have negative exponents. Okay, so my decimal point is going to go after this 5, 1, 2, 3 spaces. So 5.0 times 10 to the -3rd, or like the one that's above it, problem 1, I could just do 5 times 10 to the -3rd, and that would be fine. All right, let's take a look at this one. Decimal is going to go after my first number that's not a 0, which is the 3. 1, 2, 3, 4, 5, 6, 7. So I have 3 and 3/10 times 10 to the negative 7th power. All right, number 6, after my first digit that's not a 0, which is the 5, that's where the decimal's going. 1, 2, 3, 4 spaces over. So 5 and 6/100 times 10 to the negative 4th power. All right, let's take a look at our next problem here. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive the award? Okay, how many more tells me I need to subtract. And later in this chapter, we will be looking at how to do that with numbers that are in scientific notation. But we are going to keep our numbers in standard form. This is standard form, this is standard form. And then when we get to our answer, then we will figure out which one of these it matches. Okay, album receives an award when it sells 10 million copies. So I'm going to do 10 million. All right, and I am subtracting 8,780. Okay, 8,780,000. Okay, again, this chapter we're not using calculators, but that's okay. We can do this without a calculator. The first ones are easy: 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0. Okay, now I have 0 minus 8. I don't have something to borrow here. I don't have something to borrow here. I do have a 1 here. So I'm going to look at this as 100, and I'm going to borrow 1 from it. I'm going to make that 99, and then a 10. 10 minus 8 is 2. 9 minus 7 is 2. 9 minus 8 is 1. Okay, so now that I have all my numbers, now I'm going to change it into scientific notation. So my decimal will go in between my first two numbers, so 1.2. Then I count how many spaces I need to move. 1, 2, 3, 4, 5, 6. So I have 1.22 times 10 to the 6th power, which is C. All right, and let's take a look at this one. The table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. So here we have things in scientific notation. We can compare them in scientific notation, or we can change them into standard form to compare. We can do it either way. Okay, so I think we'll do it both ways. We'll start with the standard form, and then we will look at the scientific notation. Okay, so for 5.42 times 10 to the 8th power means I need to move 8 decimal places. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's see. I had 1, 2, 3, 4, 5, 6 zeros. Okay, so 1, 2, 3, 4, 5, 6 zeros. Okay, so Paleozoic was 542 million years ago. Okay, Cenozoic, 6.55 times 10 to the 7th. So 1, 2, 3, 4, 5, 6, 7. That's going to give me 5 zeros. So 1, 2, 3, 4, 5. And then my 5, 5, 6. So this was 65,500,000 years ago. And then Mesozoic was 2.51 times 10 to the 8th power. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to mean adding on 6 zeros onto my answer. So 0, 0, 0, comma, 0, 0, 0, comma, 2, 5, 1. Okay, earliest means the biggest number farthest away. That was, it probably would have helped if I had labeled these. Farthest away, my biggest number, Paleozoic. Okay, my next biggest number is this one, Mesozoic. And then my smallest number, which is the most recent one, is going to be the Cenozoic. All right. And then if I wanted to look at it with scientific notation, I would know the Cenozoic is the smallest number because it's only 10 to the 7th power. So just looking at that, I know that's going to be the smallest number, which is the most recent. And then these two have the same power of 10. So this part's the same, which means you compare the first numbers. So this number is bigger and this number is smaller. So it means this is the biggest one, which means it is the longest away that has happened. All right, 2 more to try on your own. Go ahead and pause the video. Try these on your own. Okay, let's check our answers. So what if in example 3, an album has sold 955,000 copies? How many more copies does it need to sell to receive the award? Okay, so remember we needed 10 million copies. How many more means we are subtracting? All right, so 0 minus 0, 0. 0 minus 0, 0. 0 minus 0, 0. 0 minus 5 takes me to the negative, so I need to borrow. I'm going to borrow from 1,000. It's going to become 999. And this 0 will become a 10. 10 minus 5 is 5. 9 minus 5 is 4. 9 minus 9 is 0. 9 minus 0 is 9. So now I'm going to make it scientific notation. I'm going to put my decimal in. And then I have 1, 2, 3, 4, 5, 6. So 9.045 times 10 to the 6th power copies. All right, and then let's see, number 8. The Tyrannosaurus Rex lived 7.0 times 10 to the 7th power years ago. Consider the eras given in example 4. During which era did the Tyrannosaurus Rex live? Okay, let's start by putting this into standard form, and then we'll see where it falls. So 7.0 times 10 to the 7th. So 1, 2, 3, 4, 5, 6, 7. So basically it is 7 followed by 7 zeros. So 1, 2, 3, 4, 5, 6, 7, and my 7. Okay, so I have 70 million years ago. Okay, so let's take a look at where that would go. So 70 million years would be between these two numbers. It's a little bit more than the Cenozoic. So it is not in the Cenozoic era. It's right in between the Mesozoic and the Cenozoic. So that's going to be part of the Mesozoic because it started in the Mesozoic. So Mesozoic is going to be our answer for this one. M-E-S-O-Z-O.